To start the virtual work lab, follow this link and click to enable the Adobe Flash Player. So it'll ask you to allow, hopefully Flash will run. And then you'll have to click green arrows a bunch of times. Okay, so this is what the lab looks like. The main parameter you're going to be varying is the mass. Notice you can vary the mass from 10 grams to 200 grams. And you're supposed to pick masses evenly spaced throughout the entire range between 10 grams and 200 grams. You need at least 5 data points, but it's up to you how many you want to do. Alright, so if you click Start, it will start the simulation. Notice a falling weight provides the force that does work on this cart, and you're going to need to read off the graph the force from this graph. And so this is kind of hard because it doesn't zoom very well, but on the force scale, notice that each little grid mark is about 1/10 of a newton. So here my force looks to be at 0.1 newtons. It looks like it's exactly on the first grid mark. So that's part of the lab. You have to interpret what the graph is saying. Also, you'll have to know this max velocity. And notice, once again, each little grid mark on the velocity scale is also 1/10 of a meter per second. And notice it's just under halfway between 0.4 and 0.5. So I'm going to say 0.44 meters per second. Okay, and my mass happened to be 10 grams. So what you're going to do is you're going to need to make a copy of this chart. And you should enter. Now remember, you have to have evenly spaced masses from between 0 and 200 grams. Probably 10 is not going to be the best. All right, and then you would enter your force in newtons. I think at 10 grams it's 0.1. And your final velocity in meters per second. And what did I say? 0.44 meters per second. So here you're going to have to calculate the work done on the cart by the spring. And notice work is force times distance. If you look back at the lab, the distance is always going to be 0.36 meters. Because remember, look at this lab. The weight only falls 0.36 meters. So that's the distance force. Notice between here and here, where it stops accelerating, is about 0.36 meters. Okay, so the distance on this graph is always going to be 0.36 meters, and you just multiply the force times distance. Since our force was 0.1 newtons, the work is going to be 0.036 joules. So I don't want to enter joules, I just want numbers in there. Alright, so I need at least 5 data points. If you want to go from 0 to 200 grams, you're welcome to pick more than 5 data points, and they should be evenly spread. And then you're going to have to do graphical analysis like we did at the beginning of the year. And I left this column blank because you're going to have to square root velocity or square velocity or 1 over x velocity, and you're going to make a graph of, well, first you should make a graph of all your velocities and all the works, and based on the shape decide what equation, and then if it's square root of velocity, you would make a new column here, square root of velocity, and then make this graph with all of this, and that will put, this will be the x-axis, this will be the y-axis. So this data set is all set up, so you can do graphical analysis just as it is. Now, in addition, so you're going to have to find the equation and the k-value that relates velocity to work. And in addition to that, read through the graph, and you're going to have to make a prediction based on velocity and the amount of mass that you have to enter. And the mass, notice I have to click New. You have to make a graph that will enable you to predict the final velocity with a graph of greater than 200 grams. All right, and you're going to have to decide what data you're going to take. Actually, you might not have to take any new data at all, but you have to figure out what kind of graphical analysis, what kind of graph you have to make a graph of, that will allow you to pick what will be the final velocity here on this graph if you had more than 200 grams of weight on this hanging mass. All right. So, and then you're going to have to do a formal lab write-up. The purpose of the lab write-up will be to verify the work-kinetic energy theorem or disprove the work-kinetic energy theorem. All right, and then you have to make whatever conclusions according to the results that you get off of this simulator. All right, good luck.